Hello guys, welcome back to the quantity surveying workshop. In today's video we're going to be treating how to measure for the quantities for a spiral staircase. So if you're conversant with measuring the quantities for a conventional or traditional like staircase, maybe a dog leg staircase, this is not any different. The only unique thing about this spiral staircase is that it is spiral. However, the quantity that you are going to be measuring for it is the same. You'll be measuring for the concrete work in the same manner that you measure the concrete work for a normal staircase. You'll be measuring the formwork, you'll be measuring the reinforcements, and you'll be measuring the balustrades that come with the staircase. So like you all know, the part of a staircase remains the same. We have the step, we have the risers and the treads, we have the waist, we have the string, we have the landing, and so much and so forth. Okay, first things first, let us try to understand what the drawing is talking about, right? Let's try to understand the drawing. So as we all know, this is our landing, right? You can see that there is a hidden details under, meaning that there is a beam under supporting the landing, as you can see in this section here, right? There is a beam, two beams supporting the landing at the sides, right? The beam ends just on the landing. There are some cases where the beam goes round the staircase also, just to support the waist. But as you can see in the drawing, there was no dotted line within the waist. The dotted line was only at the landing, meaning that it is only at the landing that we have this beam support. Now the next thing we're going to be looking at is the step. Now you know that normally if this was a dogleg staircase, the step was supposed to be rectangular, but you can see because of it is spiral, it is curving. One side is bigger than one side, right? So we can say that even though we know that this place is going to be slightly curved, you can assume that this is a trapezium shape, right? So how many steps do we have? We have 1, 2, 3, 4, 20 steps, right? 20 steps. And they told us that the internal diameter of this staircase, because you know that we know that a spiral is kind of like a 3D line. That's a line curving and moving at an altitude. However, if you look at the spiral from above, that's from the plan, you are going to be seeing a circle, right? That is why we have something like this. Although this staircase does not give us a complete circle, right? It does not go round multiple times before we get a landing, right? The staircase just ended here before we have the landing. That is why we have something like a semicircle here. So however, because of you are seeing a circle here, is because of you are seeing it from the plan. If you are looking at it from an elevation, this is what you are going to be seeing. I hope you can see this clearly. This is what you are going to be seeing. So you can see that we have a curve, meaning that the landing ended just close to where the beginning of the curve started from. This is just a caricature drawing, right? So this would serve the job for this purpose. So you can see that this is what we have. It is elevating. But if you are looking at it from on top, this is what you are going to be seeing, right? So we've done our landing, we've done our steps. Now the next one now is the waist. We know that the waist is, let me zoom in. The waist is this part here. That is our waist. So since we know that this is our waist, right? Normally in the conventional staircase, the waist is going to be kind of, let me just say, a rectangular surface that has a thickness, right? Because we know that our steps are rectangular and the waist is what gives the step support, right? The steps are on top the waist. However, this staircase is curving. So it means that the waist now is going to follow the curve. So it means that process now we're going to be using to measure the waist, the volume for the waist, is going to be what's different from conventional staircase. So these are the intricacies between conventional staircase and what the spiral staircase. Now the next thing now we're going to be looking at is how to go about this measurement. So first things first, we're going to be starting with what? The step. I'm starting with the step because we know that the landing is a regular shape, the same way as our landing is in the conventional staircase. So that one is straightforward. However, it is the step and the waist that is different, because you can see that this is not how a conventional staircase is. So now we're going to be putting more attention on the step and the waist under. So now how do we measure for the what? Step. Now you can see that our step is not a rectangle, right, just as we have in our dog leg staircase. However, this step, right, is formed in such a way that it is going to curve on top of what? The curved waist. Now if you look at this, right, you can see that this from here to here is our waist, and you can see that it is curving, making the word spiral. So now we need to find an approach that we can use to determine the length of the curve. When we do that, we can also find a way to determine what would be our what volume for our what steps on top of what that curved waist. It is very straight to the point, very easy to understand, so just pay attention. It is not difficult. Now if we go through the parameters, now we can see that our landing, they said that our landing, the length is what? 1800 millimeters, and it is as wide as what? 1600 millimeters. So now if we look at this, now they didn't tell us that the length of this step is, they didn't give us the length of this step. So because of they didn't give us the length of this step, we have to be what? Smart and find what is the length of the step. So now since we know that the length of the step is not given, how do we determine the length of the step? We use our what? Landing, because the step is going to be on the same level as what? The landing. Now if you look at this, from here to here is 1600. Look at where the step is starting from here to here, 1600. So it means that the length of each step from here to here will be 1600, here to here is 1600. The only thing why I'm saying it like this is because it is following through the what? Internal diameter, the curvature. That is why you are seeing it, that it is giving us that what? Bend, you know, that bend shape, right? But because of the giving us the length of our landing as 1600, it means that the length of each step is going to be what? 1600. It's just simple understanding of what you're drawing. So now if you look at this on our beam, right, they told us that our beam is going to be as thick as what? 150 mm, and it's going to be as long as what? 450. So we know that our waist, right, is 150. So it means that from here to here is going to be what? 150, because the waist is going to be formed in such a way that it will enter what? The landing, right? So if our waist is 150, it means that from this point here down to this point is going to be what? 150. I hope you understand the logic. Now how do we measure our what? Step. So to measure our step, now if you look at this, right, you can see that this is not what? A rectangle just in our conventional staircase. This is what? More like a trapezium. Now you can see that this place is a little bit curved, right? But we are going to be forgetting the curvature, right? We are going to be making this straight. It's going to be looking straight. Since it's going to be looking straight, now we can see that this is what? A trapezium shape. Now in cases when we have a trapezium shape, we know that volume is what? Length, width, and thickness. We already know our length of the staircase is what? 1600. Now we are trying to determine what is our what? Width. And you can see that that's for the steps. Now you can see that the step is what? The width for the step is different. The width here from here to here is different from the width from here to here. So how do we go about the calculation? Now all you need to do now is this.